Welcome to qnawire.
In this problem, we have a man running on the ground. The problem asks us for two things. First, the time will it take for the man to reach 50 meters starting from rest, assuming that a frictional force is acting on the man's shoes with a coefficient of 0.90. Next, the problem asks us for the time will it take for the man to reach full stop after completing the 50 meters. This problem involves applying Newton's law of motion and kinematic equations. To solve for this problem, we first have to find an expression for the man's acceleration. We can do that by using the Newton's law of motion. First, let's draw the forces acting on the man's body. First, its weight pointed vertically downwards. Let's denote it as F sub W. Next, the force perpendicular to the surface, which is F sub N. And the friction force opposite its movement, which is F sub K. In this case, the type of friction that's acting on the man is kinetic because the man is moving. And then the force applied by the man to make him move in this direction. We denote it as F sub A, or the applied force. Now let's write these forces, splitting it into vertical and horizontal components. First, for the vertical components, the summation of these forces in this direction, let's denote as F sub 1, is equals to 0 according to first law, where it states that a body in equilibrium, the net forces is the sum of net forces is equals to 0. In this plane, the forces are normal force and the weight of the man. We denote it as negative since it is opposite the direction of the normal force. The formula for weight is the product of the mass of the body and the acceleration due to gravity. As such, the equation becomes like this. Simplifying, the normal force stress equals to the product of mass times the acceleration due to gravity. Now, for the horizontal forces, also, the summation of the forces on this plane is also equal to 0. And the forces involving this plane are the flight force and the frictional force. From second law of motion, the applied force is just equal to the product of the mass of the body and the acceleration due to its movement. This is the value what we are looking for first. We denote it as A sub X. And the formula for friction is mu sub K multiplied by the normal force. Rearranging, we have m multiplied by a sub x is equals to mu sub k multiplied by normal force. Since we know that normal force is just mg, we can rewrite this equation like this. Dividing both sides by the mass, to simplify, we have acceleration stress equals to mu sub k multiplied by the acceleration due to gravity. Since the coefficient of friction is given, we can solve this equation. 3.90 multiplied by the value of acceleration due to gravity, which is 9.8 meter per second square. We have AX is equals to 8.82 meter per second squared, or around 9 meters. Now we have the value for acceleration. We will now use kinematic equation to get the time. The equation we will use is this one. X sub 1 is equals to x sub naught plus v sub naught x. This is the initial velocity of the man running multiplied by the time we are looking for, t sub 1, plus 1/2 multiplied by the acceleration we calculated earlier, and then the square of the time. Note that since the man, sa initial position of the man is 0, and the man started from rest, then x sub naught is equals to 0, and v sub naught x is also equal to 0. As such, the equation reduces to x sub 1 is equals to 1/2 a sub x multiplied by the square of the time. Since the time is what we are looking for, we can isolate this to the left side of the equation. The equation becomes t sub 1 is equals to square root of 2 multiplied by the distance 1, x sub 1, over the acceleration we calculated. Inserting in this equation the given values, we have 2 multiplied by 50 meters over 9 meter per second squared. This equals to 10 over 3 seconds, or around 3.33 seconds. Now we will now solve for the time will it take for the man to reach full stop after completing the 50 meters. Let's first determine the velocity of the man after 50 meters using this formula. V sub 1 or the velocity of the man after the 50 meters, is equals to v sub naught x, or the initial velocity, plus the acceleration multiplied by the time. Since we know the man started from rest, of course v sub naught x is equals to 0. This reduces the equation into v sub 1 is equals to a sub x multiplied by t1, t sub 1. Solving this equation, we have 9.0 meter per second squared multiplied by 3.33 seconds. The answer is v sub 1 is equals to 30 meter per second. As such, the velocity of the man after completing 50 meters is 30 meter per second squared. Now we know the velocity. What we are looking for now is the t sub 2. We will use the same formula. Again, rewriting. Now, v sub 1, what we're looking for is the t sub 2. So, v sub 2, or the velocity 2, is equals to v sub 1 plus the acceleration, and then multiplied by t sub 2. So we just note that v sub 1 and v sub 2 with x, since it is in the x plane. Inserting the values we obtained and the given values, then we can write this equation as isolating t to the t sub 2 to the left side equation. We have t sub 2 is equals to v sub 2x minus v sub 1x over a sub x. Okay. For the final velocity, or the v sub 2x, of course, it is equal to 0 because it stopped after some time, right? So 0 meter per second minus the velocity 1 we have after 50 meters, which is 30 meter per second, over the acceleration. But this time, since it is coming to a full stop, the acceleration is now negative. So let's denote this as negative 9 meter per second squared. Solving this equation, the answer is 10 over 3 seconds, or around 3.33 seconds. As such, the man will take 3.33 seconds to come to full stop after running for 50 meters with a speed of 30 meters per second.